Here is another question on reduction formulas and co-functions. Grade 11 trigonometry. Straightforward things. So let's say I want to answer this and I want to make sure that I get everything correct. Now, if you see 90 degrees, there is nothing to think about. It is a co-function. 90 plus theta or 90 minus theta. So that means this 90 here, the 90 falls away and the cos changes into sine. So the first one is sine squared. This is sine squared theta. I have applied co-function. Then if you see 180 or the multiples of 180, 180, 360, 720, and so on, then I know I need to apply reduction formulas. So this is reduction, reduction, reduction. Everywhere else here is the reduction formulas. Now the tan of 180 minus theta, I must be careful with the signs, please. Becomes negative tan theta because it is in the second quadrant. The cos of 180 plus theta is equal to negative cos theta because it is in the third quadrant where cos is negative. Now at the bottom here, I have the sine of 180 minus theta, which is in the second quadrant, sine theta. The tan of 180 times theta is equal to tan theta. Also, something to just keep in your mind here. In my expression, I'm doing multiplication. In most cases, we find learners who, maybe because of pressure, when someone is writing an exam, when they get here, from here they start subtracting because of these negative signs. I can protect myself from that mistake by putting negatives in brackets, so that the brackets will remind me that this is not subtraction, it is multiplication. Now we can proceed from here. After applying reductions and co-functions, you now check identities. But before I do that, I look at all my expression. I can see that tan theta can divide tan theta. That will make my expression a bit shorter. And at the same time, the sine theta can divide sine theta here because they are squared. So that means they are sine theta times sine theta. One of them will divide sine theta. And there is my answer. So from this sine squared theta, I remain with sine theta. And from cos theta, everything is divided, so I'm left with cos theta. This is equal to cos theta. The negative and the negative make it positive. This is my answer for that question. I'm done simplifying the expression using reduction formulas and co-functions. So important, I must make sure I look for this followed by identities, and then I can simplify my answer. That's about it. All right, there is another question on reduction formulas and co-functions, grade 11 trigonometry. So we definitely know that in your examinations you meet up with things like this, and it must be possible that you can get full marks here. So let's have a look at what needs to happen here. I have 180 degrees, 180, 360. If an angle is more than 90, apply reduction formulas. Nothing else. Apply reduction formulas. Interesting, in the first expression that I have, the tan of x minus 180. Most of the time, learners are used to having the tan of 108 degrees minus x instead of x minus 180. It doesn't change anything. What we know is that our reduction formulas and the cast diagram, there is theta in quadrant 1, there is 108 degrees minus theta in quadrant 2, there is 108 degrees plus theta in the third quadrant, and 360 degrees minus theta in the fourth quadrant. So now we may want to figure out, okay, so where is 108 degrees minus 100? That one is x minus 180. So if I change it and say, okay, I want to find the value of the tan of x minus 180 degrees. And here it's 180 minus theta, 180 plus theta, 360 minus theta. For someone it may be, oh, okay, so now how do I figure this out? It's very simple. The process is very, very, very much simple. So what we do is, to this expression, the negative of 180 degrees, we can measure it in the reverse direction up to here. That is my negative 180 degrees. Then x means plus x in that direction. So the angle is found in the third quadrant. But the easier way to do it is to add 360 degrees to your angle. So which means the tan of x minus 180 degrees, add plus 360 degrees here. Then we know that 360 degrees minus 180, this is the same as the tan of x plus 180 degrees. X plus 180 degrees is found in the third quadrant. So we can change it and say 180 minus x, x minus 180. We can work it out this way to get it to the form that we are used to. So now going forward, the tan of x minus 180 is the same as the tan x because it is in the third quadrant. Another tip, let's say it happens by any chance that maybe I've forgotten because I'm under exam pressure and all those kind of things. If you get your calculator, on your calculator, just to check it, you type in the calculator tan x minus 180, and in place of x you put any value of your choice that is less than 90. So I can type tan 1 minus 180 and press the equal sign. Then the calculator will tell you whether this is positive or negative. So you can check with the calculator as well. This one is positive, tan x. Then plus, the sign of 180 plus x is in the third quadrant. So it becomes a negative of sine x. Then multiplied by cos negative x. Another interesting one. This is negative. Negative angles are in the fourth quadrant. In the fourth quadrant, cos is negative. So what does that mean? It means the cos of negative x is equal to positive cos x. The negative falls away because in the fourth quadrant, cos is positive. The sign of negative x, this negative does not fall away because in the fourth quadrant, sign is negative. The same applies to tan. The tan of negative x is equal to negative tan x because in the fourth quadrant, tan is always negative. So you need to be careful as well with those negatives. Now moving on, we can now see that the value of cos negative x is the same as cos x divided by sine 360 minus x is in the fourth quadrant, but because it is squared, it will be a positive sine squared x. That is my expression. Now please be careful. I can see that these two are the same. Don't be tempted to divide them. We can't divide them if we have a negative or a positive. We can't do that. It's like in algebra, AB divided by A. I can divide A divided by A to give me B. But if I get A plus B divided by A, I can't divide A into A. This one is not correct, but this one is correct. So those algebraic expressions ideas, they are also applicable here. So what do we do from here? Remember, after applying reduction formulas and cofunctions, the next thing is to apply identities. So the tan of x is the same as the sine of x divided by the cos of x. Then minus the sine of x times the cos of x. Let me just write it properly. Minus the sine of x and the cos of x. all over sine squared x. Now, I have a fraction here. This is over 1, definitely. When you are working with a fraction, fractions are the same as the way as they are in primary school. Everywhere fractions are just fractions. To add fractions, we make the denominators the same. So I'm going to multiply this by cos x and this one by cos x. Why? Because I want to add the fractions. So the numerator of my expression will be the sine of x minus the sine of x multiplied by cos squared x divided by cos x, and then divided by sine squared x. Now, normally, if we get a fraction on top of another fraction, I prefer, it's not a requirement, but I prefer changing this division line into a division sign. So if I do that, it makes my expression just a little bit nicer. So the numerator is the sine of x. This is equal to the sine of x minus the sine of x times cos squared x divided by the cos of x. Then this division line, I'm now going to use a division sign, divided by sine squared x over 1. Then we carry on simplifying. So here I have the sine of x minus the sine of x multiplied by cos squared x divided by cos of x. Then when you divide fractions, you change the division to multiplication and you swap this and the fraction. 1 sine squared x over 1 will become 1 over sine squared x. That is my expression. Then I can now say this is equal to the sine of x minus the sine of x times cos squared x divided by the cos of x multiplied by sine squared x. That is our expression going forward. So from here, I need to be able to now think of what I can do to simplify this. So it is advisable, if there is subtraction in an expression, we can apply factorization. So factorize a common factor from the top one. It is sine x, factor of 1 minus cos squared x. I am using factorization. There is a negative sign. I am not able to cancel or divide anything if there is addition or subtraction. Therefore, I use factorization. At the bottom part, I have got the cos of x multiplied by sine squared x. This is where it gets interesting now. This part here, if you look at this bracket, we have an identity that says sine squared x plus cos squared x is equal to 1. And if you move this one to that side, you're going to have sine squared x is equal to 1 minus cos squared x. Which means in this expression, we can replace this bracket with sine squared x because they are the same. The denominator is the same as cos x multiplied by sine squared x. Now I can divide because there is no addition, there is no subtraction. So sine squared x over sine squared x. I know something about sine x over cos x. Sine x over cos x is equal to tan x. So that means the answer to this question is equal to tan x. Then my problem is solved. This one is a bit long, so I need to know what are the key areas of such questions. What do you do with 180? Reduction formula, reduction formula, reduction formula. And this one is a negative angle. Then after reductions, I notice that I have tan So change the tan into sine x over cos x. Then we created a fraction on top. What do you do when adding or subtracting fractions? You make the denominators the same. So this one is over 1, this one is over cos. Therefore, I multiplied the top and the bottom of the fraction of one fraction by cos x so that the denominators may be the same. Then my numerator now becomes sine x minus sine x. Cos times cos gives me cos squared x. So this is my whole numerator divided by sine squared x. Then from there, what did we do? We changed the division line into a division sign. Then you change the division to multiplication and swap sine squared x over 1 into 1 over sine squared x. Then what do we do next from here? We multiply. So this one is 1 times the numerator, the denominator times the denominator. That's how we got this one. Then we factor out sine x to remain with 1 minus cos squared x in brackets. Then 1 minus cos squared x is the same as sine squared x. So if we put sine squared x here, that's what we did. Then the sine squared x here and the one at the bottom, they cancel each other. Then you get sine x over cos x, which is equal to tan x. This is reduction formulas and cofunctions. So in your final examinations, in the junior examinations, expect something like this. This is trigonometry grade 11, reduction formulas and cofunctions.